This is example 1 from lesson 4.1. We are to convert 131 degrees, 12 minutes, 33 seconds to decimal degrees, and then round our answer to 4 decimal places. All right, let's see. 131 degrees can be written as 131 degrees plus 12 divided by 60 degrees plus 33 divided by 3,600 degrees. And then we put that into our handy dandy calculator, and it gives us 131.2092 degrees. Example 2, we're converting 26.48 degrees to degrees, minutes, and seconds. This is going to convert into 26 degrees plus 48 over 100 times 60, because there are 60 minutes in 1 degree. And when we put this in our handy dandy calculator, it gives us 26 plus 28.8. This means we have 26 degrees and 28 minutes. And now we're going to take 8 over 10, and we're going to multiply that by 60 because there are 60 seconds in 1 minute. And that's going to give us 26 degrees plus 28 minutes plus 48 seconds. So 26 degrees, 28 minutes, 48 seconds is the same thing as 26.48 degrees. Example 3. We're going to convert these degree measures to radian measures, and that means we're going to be multiplying by the ratio pi divided by 180 degrees. For part A, we're going to take 300 degrees and multiply it by pi divided by 180 degrees, and we know the degrees are going to cancel one another out. This is going to give me 300 pi divided by 180. Now, both of these I know are divided by 10 because they both end in 0, so that's going to give me 30 pi over 18. And then, let's see, I know 6 can go into both of these, so 6 goes into 30 5 times, and 6 goes into 18 3 times, and I believe that one is now in lowest terms. For part B, we're going to take negative 70 degrees and multiply it by the ratio pi divided by 180 degrees. Again, the degrees will cancel out. This is going to give me negative 70 pi divided by 180. And again, since they both end in 0, I know 10 can go into both of them. So that gives me negative 7 pi over 18, and I believe that one is in lowest terms. Okay, now for example 4, we're going to do exactly the opposite of that. We have angles measured in radians. Now we're going to convert them into degrees, and we're going to multiply by the ratio 180 degrees divided by pi. All right, for part A, we're going to take pi divided by 18. We're going to multiply it by the ratio 180 degrees divided by pi. And it looks like the pi's are going to cancel out. This is going to give me 180 divided by 18, and this is going to be in degrees. And it looks like 18 can go into 180 10 times. So pi over 18 is the same thing as 10 degrees. For B, we're going to take negative 7 pi over 4 and multiply it times 180 degrees over pi. Once again, the pi's will cancel out. Let's see, negative 7 times 180, 7 times 0, 7 times 8 is 56, so 1,260 over 4, and this is in degrees. And then we put this in the handy dandy calculator. Let's see, 4 goes into 12, negative 3 times. 4 goes into 6, 1. So it looks like negative 7 pi over 4 is the same thing as negative 315 degrees. Alright, example 5, we're supposed to find coterminal angles between 0 and 360 degrees. Now for A, our angle is 1,230 degrees. This is way more than 360 degrees. Alright, one thing we can do is we can take 1,230 and we can subtract 360 degrees, and we can keep subtracting 360 degrees until we get a number that's between 0 and 360. Now when I first subtract here, this is going to give me 870. And then I subtract 360 again. This is going to give me 510. And then when I subtract 360 again, this is going to give me 150. And so 1,230 degrees is the same thing as 150 degrees. They are coterminal to one another. Another thing we could do for part A is we can take 360 degrees and we can divide it into 1,230. And when we do this division, I can see in the calculator that it doesn't go evenly, but it does go 3 times. Alright, now if I subtract the 3 off on the calculator and then I multiply that decimal there, and by the way, the decimal is 0.41666 and so on, so it's going on forever and ever and ever. If I take the decimal 0.416666 and then multiply that by 360 degrees in my calculator, that is going to give me 150 degrees. And so this is another way that we could have gotten a coterminal angle for 1,230 degrees. Alright, for B, our angle we're starting with is negative 315 degrees. Now, this is less than 0, which means that we're going to have to add 360 until we get to an angle that's between 0 and 360. Well, negative 315 plus 360 in the calculator is going to give me 45 degrees, and that is within my interval. Example 6, we're finding coterminal angles again, but this time we're going to be doing it in radians rather than degrees, which means we're going to be adding and subtracting 2 pi. Alright, so for part A, the angle I have is negative pi over 8, and since it's negative, that means it's less than 0, so I'm going to have to add 2 pi. Now, if I convert these so that they have the same denominator, we'll have negative pi over 8 plus 16 pi over 8, because 8 can go into 16 2 times. So I know this fraction reduces to 2 pi. And now that they have the same denominator, I just add the numerators. Negative pi plus 16 pi, that gives me 15 pi. And we don't change the denominator, it stays an 8. And this angle falls inside my interval right here between 0 and 2 pi. Alright, for part B, we have the angle 19 pi divided by 4. This angle is actually more than 2 pi. So what I'm going to do is I'm going to subtract 2 pi, and I'll continue subtracting 2 pi until I end up with an angle that's between 0 and 2 pi. Alright, so you have 19 pi over 4. I'm getting a common denominator. Oops, that should be a minus. 2 pi is the same thing as 8 pi divided by 4, because 4 can go into 8 2 times. And then we subtract the numerators. 19 minus 8 gives me 11 pi. And then in the denominator, we don't change that. That's going to be a 4. Well, this is still too big. So I'm going to subtract another 2 pi. But I know that 2 pi, remember, is equal to 8 pi divided by 4. So let's see, 11 minus 8 is going to give me 3 pi. And again, we don't mess with the denominator. And so 3 pi over 4 is coterminal to 19 pi over 4. All right, example 7. Find the length of an arc made by an angle of 220 degrees on a circle of radius 9 inches. We are going to use the formula S is equal to R times theta. S stands for the arc length, R stands for the radius of the circle, and theta is our angle, but that angle is measured in radians. Now our angle here is measured in degrees, so the first thing we're going to have to do is convert that. All right, so in order to convert 220 degrees into radians, we're going to have to multiply it by the ratio pi divided by 180. The degrees are going to cancel one another out. This is going to give me 220 pi over 180. And now I know 10 can go into both of these because they end in 0. That gives me 22 pi over 18. And then since both of these are even, I know 2 can go in there. So that's going to give me 11 pi over 9, and that will not reduce. Now I'm ready to use my formula. All right, so the arc length S is equal to our radius 9 times our angle there, 11 pi divided by 9. This is going to give me 99 pi divided by 9, which will reduce to 11 pi. And our units on here are going to be inches because that was the units on the radius of the circle. So the arc length is 11 pi inches. Example 8. Lincoln, Nebraska is located at 40.8 degrees north, 96.7 degrees west. And Dallas, Texas is located at 32.8 degrees north, 96.7 degrees west. Since the longitudes are the same, the cities are north and south of each other. Using the difference in latitudes, approximate the distance between the cities, assuming that the radius of the Earth is 3,960 miles, and we're going to round to the nearest mile. Now, believe it or not, we are going to use this S is equal to R times theta formula because the Earth is spherical in shape. All right, so the first thing it told me to do was use the difference in the latitudes. That means our angle is going to be 40.8 minus 32.8, which means that our angle we're going to be using is 8 degrees. All right, the next thing we want to do is we want to use our formula here because we have our radius. They gave it to us right here. We have our angle, but the angle is not in radians. So let's take our 8 degrees and multiply it by pi over 180 degrees. This will give me a radian measure. The degrees will cancel. This will give me 8 pi over 180. And let's see, 4 can go into 8 2 times. And 4 can go into 18 45 times. So it looks like my angle is going to be 2 pi over 45. All right, let's put it into our formula. The arc length, in this case the distance between the cities, is going to be the radius 3,960 times our angle 2 pi over 45 radians. And when I put this into the calculator, it gives me 176 pi, and our units are going to be miles, and that's because the radius is measured in miles. And then if we convert that and multiply 176 times pi and round it up to the nearest whole number, to the nearest mile, we get about 553. So those two cities are about 553 miles apart.